Hi guys, good evening. Guys, please confirm. Guys, please confirm. Hi guys, good evening to all. Guys, please confirm
Recording in
once. Is
progress.
my voice and screen is my screen is visible and my voice is audible? Please confirm in chat box once. Please respond in chat box, guys. Fine. Thank you, guys. Sorry, guys. Actually, it has to start yesterday itself. I'm not feeling well yesterday. That's why it postponed to today. Right, guys. Today, so we are going to start our discussion about Docker and Kubernetes. So today is the first class of Docker and Kubernetes, guys. Guys, right, as a DevOps engineers, if you guys want to attend for the interview, these two things are very important. Without having complete knowledge and right hands-on experience on these two tools, right, you guys can't able to clear the interview. So not only for DevOps engineers, guys, even whoever working at Java side, for those people also Docker and Kubernetes are very important. Right, guys? See here, first what we are going to discuss in this two. First we are going to discuss Docker, guys. Once Docker is completed, we will move into this Kubernetes. Right, in entire our DevOps tools, Kubernetes is the very difficult tool. Right, if you guys want to understand this Kubernetes, Docker knowledge is mandatory. Without having Docker knowledge, we can't able to understand this Kubernetes. Right, what we are going to learn in this Kubernetes? Right, see here, by using Docker, we are going to create the containers. Whatever the containers we are creating by using this Docker, we need to manage those containers. Right, so to manage those containers, we are going to use Kubernetes, guys. Understood, guys? Right, what we are going to do with Kubernetes? We are going to manage the containers which are created by using Docker. See, guys, Docker is what, guys? Docker is a containerization tool. By using Docker, we are creating the containers. That's why Docker is a containerization tool. Right. So by using Kubernetes, we are going to manage the containers which we are creating by using Docker. So Kubernetes is a orchestration tools, guys. Docker is a containerization tool. Kubernetes is a orchestration tool. Do we have any other orchestration tool right apart this Kubernetes, guys? Only Kubernetes we have, or do we have any other orchestration tools we have to manage the Docker containers?
Docker Swarm.
Docker Swarm, very good. We have Docker Swarm also available to manage the Docker containers, right? Docker Swarm also we are going to understand in these sessions, guys. Docker Swarm and Kubernetes. But most of the companies, 99.99% companies will use Kubernetes only. Kubernetes is the alternative for Docker Swarm, guys, not for Docker. Not for Docker, Kubernetes is the alternative for Docker Swarm. See, guys, why Kubernetes have this much popularity means right, already Docker Swarm is available. Docker Swarm is coming from Docker only, right? Whoever released, right? Whoever managing this Docker Swarm also managing by that company only, right? Then why people still using Kubernetes? Why people still using Kubernetes, guys? See, guys, by using Docker Swarm, we can able to manage the containers which are created by using Docker only. And we can create containers in so many ways, guys. Not only with Docker, we have other containers also. Other ways also we have to create the containers. But here, by using Docker Swarm, we can able to manage the containers which are created by using Docker only. But by using Kubernetes, guys, any type of containers we can manage by using containers, guys. Not only the containers which are created by using Docker. Any other type of containers also we can manage by using Kubernetes. Okay, we will discuss all those things in Kubernetes session. Right, see guys, our course name is Docker and Kubernetes. Right, first we are going to start with Docker, guys. Right, in Docker what we are going to learn? In Docker what we are going to learn, guys? See guys, first we are going to understand what is Docker. What is Docker we are going to understand. So next, why Docker? Why Docker is required? Why Docker is required? Right, if you don't have the Docker, right, what is the problems we will face? Right, if you don't have the Docker, what problems we will face as a DevOps engineers? If you don't have the Docker, what problems we will face as a DevOps engineers also we are going to discuss it here. Next, we are going to install the Docker. Docker installation. Docker installation. Next, we are going to understand Docker architecture. Docker architecture we are going to understand. Next, we are going to understand, after this Docker architecture, we are going to understand the important commands what we have in the Docker, guys. Docker commands we are going to understand. Docker commands we are going to understand, guys. Right. So next, guys, Docker files. How to create the Docker files? How to create the custom Docker files? All those things, guys. Working with Docker files, guys. Docker files, how to create the Docker files and all those things we are going to discuss it here. Next, guys, right, how to create the images, how to create the working with the Docker images, working with Docker images. See guys, here we are understanding how to create the Docker files. Right, from this Docker file we can able to create the Docker images. From the Docker files, how to create the Docker images and all those things we are going to understand it here. Right, see guys, here we can use the images which are available in the registry. We have the Docker registry is available. Inside the Docker registry we have Docker images are available. Right, we can use those predefined Docker images, and based on your requirement you can create your own Docker images also. Right, before creating the Docker image, you should create the Docker file. From the Docker file, we will create the Docker images. How to create the Docker files? How to create the Docker image, custom Docker images from the Docker files? All those things we are going to understand. Right, guys? Right, once this Docker, right, working with the Docker images is completed, right, from this Docker images, we will create the Docker containers. From this Docker images, we can create the Docker container. See guys, this is very, very important, these three things. If you have the Docker image, from this Docker image, we can create any number of containers. Right, those containers we can run on any number of machines, guys. See guys, in the companies I have, multiple environments are available. Dev environment, sit environment, UAT environment, right, production environment, like that several environments are available. If you have this Docker image, right, with this image you can able to create the containers. You can run those containers in all the environment, guys. Right, how to create the Docker files, how to create the Docker images from the Docker file, how to create the Docker containers by using Docker images. First files, next images, next containers, guys. From the files we are creating images, from the images we are going to create the containers. Right, guys. Next, right, we are going to understand volumes. Right, volumes are nothing but storages, guys. Here we are going to understand Docker volumes. Docker volumes we are going to understand it here. Next, right, Docker compose. Docker compose, guys. Here you guys should know how to write the YML files and all those things. Right, in Docker and Kubernetes, both the places we are going to write the YML files only. Docker compose, in Docker compose, everything we are going to write the YML files only at here, guys. Docker compose we are going to discuss. Docker compose. Once Docker compose is completed, we will talk our discussion about, right, see, Docker swarm, guys. Docker swarm, we will discuss it here. Docker swarm, we will discuss it here, guys. Please go through this content, guys. So these are the things which we are going to discuss in our Docker sessions, guys. Please have a look into this. And here I am going to show how to Dockerize the real-time project also. Right, real-time project. Right, I will take one Spring Boot. Right, the application which is developed by using Spring Boot and microservices. I will Dockerize that project, guys. So all these things we are going to discuss in our Docker sessions, guys.
Hello.
Yes.
So can I ask a doubt, please?
You can.
So do we have any prerequisites to join this Docker and Kubernetes?
So you guys should know how to write the YML files and all those things. So no problem here. Anyway, we will discuss. I will show how to write the YML files also. So you are working at development side or DevOps side?
No. I am working as an admin, not a development side. I am not a developer. I am working as an admin. I do not know the coding part.
Okay, no problem. Here, just we should have some basic knowledge on the YMLs. How to write the YML file, right? How to take the indentations, what is key, what is parent key, what is child, right? Those kind of basic knowledge is required. No problem. I will cover that part also here.
Okay.
I will show how to write the YML files also. So for DevOps people, whoever working, right, whoever attended for our DevOps sessions, right, in Ansible, we discussed it clearly how to write the YML files and all those things. Same YML files we are going to write in Docker and Kubernetes also. We need to write the YML files only.
Okay.
Don't worry, that the YML part I will take care. No problem.
Okay.
Right, guys. So these are the topics which we are going to discuss in our Docker sessions. Once a Docker is completed, so next I will start Kubernetes, guys. Kubernetes, I will start it here. In Kubernetes, what we are going to discuss. See, guys, Kubernetes is very, very, very huge content is there. Right? We need to spend a lot of time in Kubernetes, guys. Kubernetes is very difficult and very, very important also. In our entire DevOps tools, Kubernetes is the very difficult tool and it will take a lot of time also to understand. Right? Even that Kubernetes architecture also very big, guys. Too big, that Kubernetes architecture. See here, let me open Kubernetes architecture once. Kubernetes architecture. To understand that Kubernetes architecture only it will take 2 days of time. Only to understand that Kubernetes architecture, we need to spend 2 days time, guys. See, guys, so many components are there in Kubernetes. See, guys, right, we need to understand all these things. What is kubectl? What is user interface? This is the master node, guys. In master node, we have API server, scheduler, controller manager, etcd. Coming to this worker nodes. See, guys, what we have? Pods are there. Inside the pods, we have the containers. Next, Docker is available. Docker runtime. This one is Docker runtime, guys. Here, kubelet is available. Kubeproxy is available. Right? Each and everything we need to understand one by one, guys. Right, we should understand what is API server. When user send the request, first that request will come to the API server. API server will store that information inside the etcd. Next here, scheduler will talk with kubelet. Kubelet will check, right, any space, anything, right, is any containers or any pods are available to run this request. Kubelet will check with right, worker node components, right, if it is any availability to run that request, it will give the update to scheduler. Scheduler will take the help of controller manager and it will take the, right, all these components. All these things we need to understand one by one, guys. The architecture itself too big. See how many things are there inside the architecture. Guys, daily attend the live sessions, guys. You guys, right? So anyway, recorded videos are sharing, right? We can listen those recording videos later. Don't think like that, right? So you guys will get so many doubts once you guys have started the practice. Right, doubts I can able to clarify in the live sessions only. If you guys are only listen that the recordings, there is no use. When you guys are practicing, you guys will get more doubts in Kubernetes. Right, if you guys want clarification on those doubts, you should attend for the live sessions. Okay, fine guys. What we are going to discuss in our Kubernetes guys? What we are going to discuss? First we need to understand what is Kubernetes. First we need to understand what is Kubernetes. Next we need to understand how Kubernetes will work. How Kubernetes will work. Right. What is Kubernetes cluster? We are going to clear the cluster set here. What is Kubernetes cluster? Kubernetes cluster. Right. Next here, Kubernetes architecture. Kubernetes architecture. Kubernetes architecture, right? Just now I have shown architecture. So that complete architecture we need to discuss. Kubernetes architecture. Next here, master components. How master components will work? How master node components so will work. Right. Next, how node components will work. How node components. See guys, in this diagram you can see. So this is the master guys. This is the master. These are the worker nodes. These are the worker nodes guys. Right. How worker node components are working. How worker node components will work. How worker node components will work. Right. So next, how pods. What is pod? Pod is nothing but set of containers, guys. How pods will work? How pods will work? Next, installation process. Installation process. Installation process. Next, configuration Kubernetes cluster. Configuring Kubernetes cluster. Configuring Kubernetes cluster. Next, pod lifecycle. Pod lifecycle. Next, working with the pods. Already I mentioned, right? Working with pods, right? Working with the services. Working with services. Next, Kubernetes. Kubernetes short form we will call it as K8s guys. Kubernetes ingress. Kubernetes ingress we will discuss. Next, Kubernetes K8s. K8s Helm. K8s Helm. Right, deployments with services. Deployment with services. Right, all these things we are going to understand in Kubernetes guys. Right guys, please go through these things. Right. This is the content which we are going to discuss in our session guys. Right, what is the duration guys? Duration. Right, 25 to 30 hours is required guys. 25 to 30 hours is required to complete all these things. 25 to 30 hours is required to complete all these things guys. Right, daily class timings. Class timings. daily 7:30 guys. Class will start by 7:30. 7:30 to right 7:30 to right. So 8:45. 8:45 right or 9 right 9 o'clock I have another session, so that's why 7:30 to 8:45 to 9 it will go, sir. 7:30 to 8.
In the evening or in the morning?
Evening, sorry, evening guys, evening, same time, right? 8:45 to 9 it will go, right? 9 o'clock I have another session, that's why I need to stop before 9, right guys? Daily class notes is available. See guys, in notepad everything I will write. You guys not required to take any running notes. You guys not required to prepare any notes guys. Here I will write each and everything. Right, for you guys I will prepare the notes. Right, in front of you guys only I will prepare the notes guys. I'm not going to download from any website guys. Whatever I'm explaining, everything I will put in the notepad. I will put in the notepad right at the end of the session. Once session is completed, I will share that notes. Daily class notes I will share, and daily class recordings also available, right, with 3 months access. Class recordings only 3 months access guys.
So, sir, these are the things which will be helpful in the real time, right?
Yes, real time I will show. Complete project I will take and I will show practically how I am doing in my company. Practically I will show guys.
Okay. How to create
everything here, whatever I mentioned from scratch till end, everything I will show practically.
How to write YAML files.
Yes.
Do we need to have any cloud account to practice this session?
AWS guys.
Okay, we need to have a AWS
account. Free tier account. We can create the free tier account in AWS. We need to create that free tier account. So there we have EKS is there guys. Kubernetes, Elastic Kubernetes is there. Service is there. We are going to use that service at here. If you are not using that service, right, just to set up the to set up the missions only, minimum 50 to 60 commands we need to run. I will show that the manual process only without using EKS. How to do that? I will show that one also. Right, and we need to understand, right? Then only first you need to see the difficult part. Then only with the AWS service, how much quickly we can complete the process, we'll get to understand that. That's why first I will show complex part, guys. Manually, how to set up the missions. And for that, we need to run 50 to 60 commands, guys. 50 to 60 commands we need to run manually. Right? So same thing we can do by using AWS providing EKS service very easily, right? Guys, here we need to create the AWS account, free tier, 1 year free tier eligible account is there. That account we need to create.
Sir, as you said, a YAML files, I mean, so we need to write the code in a YAML. So guys, can we have a glance of that at least now?
No, one thing guys, see here inside the YAML, we are not going to write any Java code, any Python code. That is not a programming language, guys. YAML is not a programming language. That is just a file format. How we have the .txt file, how we have the .xml file, how we have the .xls file. Same way, .yml is nothing but one extension for the files. Inside the .yml, data is key value pairs. That's it, guys. We are not going to write any code inside the YML files. Everything we are going to represent in the form of key value pairs. That's it. Key is nothing but, see here, if you take a equal to 10, and here a is the key, value is the 10. So like that, everything we need to represent in the form of key value pairs, guys. That's it. We are not going to write any code inside that YAML files. YAML is not a programming language. YAML is not a framework, nothing, guys. Just it is a file format.
Hello, sir.
Yes.
Hello.
Yeah, tell me.
Sir, are you going to show about real-time deployment in Kubernetes, sir?
Yeah, I will show. Like Kubernetes, Docker, how to create and how to deploy the Spring Boot. I will take Spring Boot microservices project. I will take. Actually, I'm working at Java side also. So that's why I will take Spring Boot and microservices project, and I will show how to deploy in Kubernetes cluster and everything.
Okay, fine, sir. Thank you.
Hello,
Yeah.
sir. I want to know by learning like Kubernetes and Docker, is it like we can enter a DevOps roles
No.
or
No. These two things are not enough.
Okay. So
These two are the part of DevOps tools, guys. These two tools are not sufficient, guys.
Sir, this will be helpful for Azure DevOps as well.
For Kubernetes and Docker is different. Azure, and if you take that cloud related thing, either Azure or AWS or GCP, anything, Docker and Kubernetes is the same, guys. There is no difference in this Docker and Kubernetes. It will helpful for any cloud technology.
Okay.
so sir, like if I'm looking for a job, then like only with Kubernetes and Docker, it is difficult to.
No, it is not sufficient. You should know some cloud technology and right. You should here in DevOps sessions. I am covering 15 plus DevOps tools. So out of those 15, these are the two tools. That's it, guys. 15 plus DevOps tools I am covering. All those 15 plus DevOps tools are required to attend for the interview. At the same time, I'm covering AWS service also. 20 plus AWS services I'm covering. And if you want to join as a DevOps with the AWS cloud, it compulsory you should know all those AWS services and you should know all these 15 DevOps tools also. Only Kubernetes and Docker is not sufficient to join as a DevOps engineer. Okay. Fine, guys. So this is the course content which we are going to discuss, guys. Right, the duration of the course is 25 to 30 hours. It will take. Class timings daily 7:30 p.m. to 8:45 p.m. Right, the daily class notes I will share. Right, the daily class recordings also available. Right, class recordings only 3 months access, guys. Only 3 months access. Right, we will create the Telegram group. In the Telegram group only we will share class notes and class recordings. Right, while you guys are practicing, if you guys have any issues, right, please take the screenshot and put it in the Telegram group only. I will respond, guys. You guys not required to wait until tomorrow's session. You guys not required to wait until next session, guys. Whenever you face the issue at the time of practicing, take a screenshot and put it into the Telegram group. I will respond for that.
Okay, sir. So one more question from my side is that
Yeah.
by attending this class, will I be able to take up the certification, that is CKA certification for Kubernetes, or it is just a basic?
This is not basic, guys. This is not basic. Right, Kubernetes in depth we are learning. You can write the certification also on Kubernetes.
Okay.
This is not basic. The complete end to end we are learning Kubernetes here.
So like if you want to set up a lab in my laptop, so what should be the
I will show guys here in my system from scratch. I will set up everything. Right, so I will show that record. You guys can go through that record and you can do from your end.
No, I want to know like what configuration of my laptop is required.
So what you have the configuration?
I have 16 GB of RAM.
Okay, so 16 GB RAM, it is more than enough. Right, why that much is not required? Why? Because right here, right, so we are not going to create any missions in our personal laptop. We are going to connect with AWS. Inside the AWS, we are going to create the virtual missions. Inside that virtual mission only, we are practicing all these things.
Okay.
So in our laptop, in our Windows operating system, we are not going to do anything. Right? We are going to connect with AWS cloud. Right? In that AWS cloud, we will create the virtual missions. Inside that virtual missions, we are going to set up everything.
Network is required.
Right? Everything there only we will take care.
Like for to attend the examination, they have some different lab setup, right? So can we practice all those steps in this lab?
Steps in the sense?
To achieve the certification, to complete the certification. So I need to go and practice more, right? So I can do all those practice in this lab, right?
This is the online class, right? Do you want to come for our physical offline lab sessions?
No, I want to practice the same lab as for exam as well. So I can do that, right?
So lab things, right, you need to practice at your home only. In your laptop, at your home only, you need to practice.
I think he's not able to understand that after creating account in AWS, he can do everything at his home only, right? By
Correct.
accessing the
Correct.
AWS server.
Correct.
No, that is not my question. My question is like, I want to go for certification. So I can practice all those certification content which is required to pass the exam. That all topics.
It's up to you, right? It's up to you whether you want to practice or not.
That dumps you are asking, that dumps questions, dumps and all.
No, not dumps, like the concepts which is
Concepts are same. Concepts are same. These concepts in these concepts only you will get how to do this setup, how to do that setup, like that. They will ask questions like this only. Here everything we will cover, but practice is up to you. How you will practice, that up to you.
Yeah, that I'll do. Like you will cover all the topics.
Yeah, I will cover all the topics. I will cover all the topics.
Do you have any like model questions which they are going to cover?
That I need to check once. I don't have that certification exam wise. I don't have any questions. I need to check it once.
Okay.
Fine.
Got it.
Fine, guys.
So one more
Yeah.
question from my side is that the duration which you are given is 25 to 30 hours.
Hmm.
Does it include even the Docker? It is only for the Kubernetes?
No, Docker plus Kubernetes both. Kubernetes will take more time. For Docker, I need 8 to 9 days is enough for Docker. Right. For remaining time, I will spend with Kubernetes only.
Okay, and this is a complete weekday classes or only on the weekends?
No, weekdays.
Sorry,
Monday to Saturday.
Monday to Saturday.
Yeah.
Okay. Okay. It's okay. So if I miss some classes, so the recording will be available.
Recordings are available with 3 months access.
Okay, sir. Okay, understood. I joined a bit late, so
Okay, no problem.
I think you might have already told all these things. Sorry for that.
Guys,
Can't
okay.
we download the recording, sir?
No. That online link through online, that link only you can able to listen those recordings. Downloads is they won't Zoom. They won't provide the download option there.
Okay.
Right, guys. Fine. So let me start, guys. Guys, tell me, what is a software project, guys? What is a software project? Anyone have any idea? What is software project? Right. Software project is nothing but what, guys? Collection of programs. Right. Inside the project, what we are developing, programs we are implementing. Software project is nothing but collection of programs. Right. So when you are developing, when you are working with the software project, right, so you can see several components, guys. Software project is a collection of programs. Collection of programs. Right, yes. When we are working with software project, we can see several components. Right. In software project, otherwise software project contains several components. What components are available, guys? One is front-end component. Second one is back-end component. Third one is database component. So these are the 3 components are available in the software project, guys. Software project contains these 3 components: front-end component, back-end component, database component. What is a front-end component? Whatever user can able to see on the browser, that is called as front-end. Whatever user can't able to see on the browser, that will come under back-end side, guys. See, guys, we have 3 components. One is front-end, second one is back-end, third one is database. Any software project, if you take any software project, these 3 components are available. See, guys, let me take make my trip application. Let me take make my trip application, guys. See, guys, whenever I have opened this application, what I can see it here, see, guys, here I can book the flight, I can book the hotels, I can book the homestays, holiday packages, trains, buses, etc., etc. Whatever we can see on the browser, this part we will call it as front end. So whatever we can see on browser, this part we will call it as front end. Now here we need to give the from address, to address, departure date and search. Right? Whenever you click on the search button, one request with all this input, whatever the input you have provided it here, from, to, date, with all this input, one request will go to the backend. Right? At backend, we have some program. Some programs are available, Java programs or Python programs or .NET programs. There we have written some logic, guys. Array, take the input from the request and check in the database. Check in the database on that date, right? From Delhi to Bangalore, what flights are available? Check in the database and get those details and send it back to user interface. Like that, we have implemented some program at backend side, guys. But as a customer, you can't able to see that part on the browser. Backend, whatever the code I have written, whatever the Java program I have written, that Java program you can't able to see on front end. Right. So same way, right, Java program will communicate with the database to fetch the details. That database also you can't able to see on the browser. Whatever you can see on the browser, that is called as front end. Whatever you can't able to see on the browser, that is called back end. See, if you want to develop this front end part, we have so many technologies we need to use, guys. What technologies we need to use to develop the front end part? HTML, CSS, Bootstrap, jQuery, Angular framework. So these are the different technologies we have to develop the front end applications. At the same time, if you want to develop the backend application, right, we will use Java version, Spring Boot, Hibernate, microservices. These kind of things we will use to develop the backend application. Coming to database, we can use Oracle servers, MySQL DB server. These kind of things we can use for a database. Guys, try to understand why I am explaining all these things. See guys, let me open one Paint. See guys, here this is the front end layer. Right, this is the back end, guys. Right, see here we have the database. Here we have the database at here. Here we have some database, guys. This is my database, guys. See guys, right, in the front end, user, whatever user can able to see on the browser, that part we will call it as front end, guys. This is my front end. Front end, guys. So this is my back end. This is my back end, guys. So this is my database. This is my database, guys. See guys, right, inside the backend, what we will write, guys? Here we will write business components and persistent components. We will write it here. Inside the backend side, we will write, right, the backend web components. We will write web components. Web components we will write, and here we will write business components. Next we will write persistent components, guys. Right. So in backend side, we will write all these things, guys. Web components, business components, persistent component, everything we will write in the backend side, guys. See, from UI, request will come to the backend application. Right. Backend application will communicate with the DB and get the details and send it back to UI. See, guys, here from UI, request will go to the backend. Right. From backend, it will go to the DB. Right. In the DB, it will search for the based on your input. It will search in the DB and it will fetch the details. And again, it will give it to you. Right. Again, you can display on the browser at here. See guys, now I want to develop this front end application. For developing this front end application, what I am going to use? right? I'm going to use HTML and CSS I'm going to use, right? Next year I'm going to use Bootstrap I will use. Next I'm going to use Angular. Next I will use jQuery, etc. All these are the related to front-end technologies. Guys, you guys no need to learn all these things. Don't worry. Right, coming to this backend. If you want to develop backend, I'm going to use Java 1.8 version. Right, Spring Boot, right, 2.x version something I'm using. Next here, Hibernate, right, 5.5 version something I'm going to use it here, guys. See, Java 1.8, right, Spring Boot, Hibernate something I'm using it here. Coming to DB, MySQL DB, right, coming to version something 8.5 version something I'm using it. All these things I'm going to use, guys. See, guys, if you want to develop one software project, right, I need to install all these things. All these things are required in my application. All these technologies which I am going to use in my project, guys. HTML, CSS, Bootstrap, Angular, jQuery. I will use all these things for front-end development. Java, Spring Boot, Hibernate, all these things I will use for back-end development. MySQL I will use for database. Guys. Right. So now, by using all these things, I have developed one application, guys. By using all these technologies, I have developed one project. Now, I want to run that project, guys. Right, I want to run that project. What we need to do, guys? Right, if you want to run that project, we need one machine, right? We need one server, right? Inside that server also, all these things you should have, guys. You should have all these things in that server also. In your local system, you set up all these things, guys. You installed all these things and you have created one project. Now, you need to deploy this project in one machine, in one server, right? In that server also, whatever you have in your local system, all those things must be required in that machine also. Then only you can run this application in that machine. You will say, "Array, application is working fine in my machine." But they will say, right, you deployed in one server, right? Right, there one person is there to check in that server. QA team is available. QA team is testing in that server machine. Right, they will tell your application is not working. Your application is not working, they will tell. Right, you are what? You are telling, "Array, application is working fine in my machine." Right, why it is not working in your machine? Like that you will tell, guys. See, in that machine also, you should have all these things. Then only that application will work. Otherwise, it won't work, that application in their machine. Whatever the softwares you have in your machine, all those softwares compulsory we require in server machine also, then only that application will work. In order to deploy our application in a machine, we need to set up all the softwares which are required to run our application. See, guys, in order to deploy our application, in a server, we need to set up right, all the softwares, we need to set up all the softwares which are required to run our application. See, guys, in order to deploy our application in a server, we need to set up all the softwares which are required to run our application. See, guys, what softwares you required, guys? Right, we need example, we need operating system we required. Right, Java 1.8 or something. Which version you want, you can take any version. The latest version of Java is the 19. Right, Java is required and MySQL DB is required. MySQL database is required and Tomcat web server is required. Next here, right, I want a Tomcat web server, everything with versions I am taking, guys. Tomcat 10 I am taking, 10.0 I am taking, Tomcat 10.0 I am taking, right, etc. etc. guys. So like this, we need these softwares in server machine also. Operating system, Java, MySQL, Tomcat, all these things. Guys, now understand, observe carefully. Why this Docker is required? Now you guys will get the clear picture. Right, observe carefully, guys. Here what I am going to do. Right, guys. So in my project, I have multiple developers are working in my project, guys. In my project, multiple developers are working. Right, assume 3 developers are working in my project, guys. 3 developers are working in my project. Right, developer 1. Developer 1, guys. Same way, we have other 2 developers also. Developer 2, developer 3. Right, total 3 developers are working in my project, guys. So this is my development team. This is my development team, guys. This is my development team. What development team will do, guys? Based on client requirement, they will develop the project. They will write the code, guys, by using Java or Python or .NET. They will write the code based on the client requirement. Okay, right. The development is completed. What they need to do, whatever the application they developed, they need to upload that code into one remote repository. Whatever the code they have written, that code. See, guys, all 3 people are working in different tasks. Right, developer 1 is working on sign up page, developer 2 is working on login page, developer 3 is working on dashboard page. All 3 people are working on different functionalities. Once development is completed, they will test in their local machine whether those applications are working fine or not. Once application code is implemented, they will test the functionalities in their local machines first. Right, it is working fine. Next, what they need to do, they need to upload entire code into the GitHub repository. So this is my GitHub repository, guys. They need to upload the code into this GitHub repository. GitHub is the remote repository, guys. GitHub repository. GitHub repository, guys. Once development is completed, development team should upload the code into the GitHub repository. Now our DevOps team will come into the picture. Right, our DevOps team. Right, this is the DevOps guy. This person is the DevOps person. What DevOps people will do, guys? What DevOps people will do? What he will do? Right, he will take the code from the GitHub repository. He will take the code from the GitHub repository and he will deploy that code into the servers. See, if you go to any companies, we will have multiple environments, guys. Multiple environments are available. What environments are available, guys? See here, this is my dev environment. Dev environment, development environment. Next here we have, right, sit environment. Sit environment we have. Next we will have UAT environment. UAT environment. Next we will have pre-prod environment. Next we will have prod environment. So like this, we will have several environments. The companies, we will have all these environments, guys. Development environment, dev environment. And next one is the sit environment. Next one is the UAT environment. Next one is the pre-production environment. Next one is the pre-prod environment. So last one is the production environment. If you deploy the application in the production environment, means that application in live. Customers can able to access that application. All these the environments are available, guys. The real time, you can see all these environments. You can see all these environments in real time. See, guys, developers are implemented the code and they uploaded the project into this GitHub repository. What DevOps engineers need to do, they need to take the code from the GitHub repository and they need to deploy the project into development environment, sit environment, UAT environment, pre-prod and production, guys. In the companies, right, we will deploy the project in only one environment or multiple environments. Multiple environments we will deploy, guys, not in single environment. the companies, we will deploy the project in multiple environments. What environments are there? So these are the different environments which we have. We need to deploy the project in multiple environments. Okay, guys, if a DevOps engineer wants to deploy the application in dev environment, what we required in this dev environment, guys? Setup is required. Setup is required, guys. What setup is required, guys? Right, in his mission, in developer missions, whatever the softwares they installed, whatever the softwares they used to run this application, to develop this application, right, all those softwares compulsory required in all these environments also. See, guys, assume in development environment, I'm taking these missions, these softwares, guys. I'm going to take all these softwares. And here I will take Linux server, Linux operating system I'm taking, it plus Java 1.8 I'm taking it here. Java 1.8 I'm taking, right, plus here I'm going to take Spring Boot, right, 2.x I'm taking, Spring Boot 2.x I'm taking. Next here I'm going to take MySQL, guys. MySQL version I will take, right, 8.5 something I will take it here. MySQL I'm taking it here, guys. See, guys, if you want to run the application in this development environment should contain all these softwares. Then only you can run that application in dev environment. Same way, if you want to deploy the application in sit environment also, we should have all these things, guys. We should have all these things in sit environment also. We should have all these things, guys. Guys, observe carefully. In development environment, whatever we are taking, all these things we required in, right, sit environment. All these things we should required in UAT environment. All these things should required in pre-prod environment. All these things should required in production environment also. See, guys, we require the softwares in all these environment, guys. Here, what is the challenging task for the DevOps engineers, guys? Installing the softwares in all the missions, right? A very big challenging task for the developers, DevOps engineers, right? Installing, setup, guys. Setup, we need to set up these missions with all these softwares. We need to set up these environments with all these softwares. That is the very, very challenging task, guys. See, guys, in this mission, I'm taking in dev environment, I'm taking Java 1.8 version. In sit environment, I'm taking Java 12 version. In UAT environment, I'm taking Java 16 version. In pre-prod, I'm using Java 18 version. In production, I'm going to use Java 19 version, guys. See, guys, environment to environment, Java versions are changing, guys. Right? When your application will work, no, guys, application won't work. If this application wants to run, compulsory, I should have Java 1.8 in all the environments. Then only my application will work. Right? Okay. Here MySQL 8.5 is there. In dev environment, one version is there. In sit environment, something different version. In UAT environment, something different version. Right? No, it won't work. In all the machines, we should have same versions, same softwares. Then only your application will work in all the machines. Here, the biggest challenging task for the DevOps engineers is, right, configuring these missions. Configuring these missions, guys. All the missions should be stable. All the missions should be stable, guys. Right? In all the missions, same versions are required. The challenging task for the DevOps engineer is configuring these environments is very big challenging task, guys. Understood, guys? Understood? It is very, very problem, guys. So now observe carefully, guys. Now, instead of doing this activity manually, Docker is going to do this activity. Docker will do that, guys. Right? Docker will do. Right? Docker, right? In that Docker, right? So we are going to, right, put all these softwares, guys. Whatever the softwares you required, right? We are going to take all those things in the container. That container I will run in dev environment, sit environment, UAT, pre-prod, production, everywhere. whatever the application they uploaded in the GitHub repository, that application, and whatever the software they are using in their systems, all those softwares I am going to package inside the Docker, guys. And right inside the Docker image, I will take from that Docker image, I will create the Docker container. That Docker container I can run on any environment. See guys, here whatever we are using, same thing I am taking and in the Docker image. Right, from that image only I am creating the containers. See guys, observe carefully guys. Earlier, how people use it to work, guys. How people use it to work. Observe carefully. Right, here we have this, guys. See here, earlier people use it to work with these things, guys. In real time, let me write these points first. In real time project should be deployed into multiple environments. Real time projects. 1 minute. In real time, project should be deployed into multiple environments, guys. In real time, project should be deployed into multiple environments. What environments, guys? These are the different environments what we have. Dev environment, sit environments, UAT environment, right here, pre-prod environment, prod environment. These are the different environments are available. We should deploy our project in all the environments. Right. So dev environment will be used by the developers to perform integration testing. Who will use this dev environment, guys? Developers will use this dev environment. Who will use the sit environment, guys? Who will use the sit environment? Sit stands for system integration test. SIT stands for system integration test. This sit environment will be used by the testers. In our project, we have the testers, right? Testers will use this SIT environment to test the application functionalities. UAT environment. Once our testing team is completed their testing, next, right, the UAT. UAT stands for user acceptance test. User acceptance test, guys. Client will test, guys. Client will test the functionality. For that, we need to set up one mission with the name UAT, user acceptance test. User will check. Customer will test the application, how it is working. Next, guys, pre-production. Right, before sending to production, we need to test our application with the real data in pre-production environment. Right, in pre-production environment also it is working fine. Then we need to deploy the application in production environment. Production means what? Live environment. Live environment, guys, right, where people use it to access the application, that is called production environment. Production means what, guys? Live environment. Development, dev means right, where developers will do the integration test, that is called dev environment. Where testers will do the right functionality testing, that is called sit environment. Where client people, users will do the testing, that is called UAT environment. Pre-production means before deploying the application into production environment, we need to test the application with the real data, that is called as pre-production environment. Production means live environment. So these are the different environments are available in the companies. Right. If you want to deploy the application in these many environments, we need to take off all the softwares required to run application, right, in all the environments, guys. To run the application, whatever the softwares are required, we need to take all those softwares in all these environments. If you want to run my application, you should have Linux operating system, you should have Java 1.8, you should have Spring Boot 2.5, you should have MySQL 8.5, you should have Tomcat 10. All these softwares are required. So all those softwares we need to take in all the environments. Here, whatever the environments we have, in all the environments, we need to install those softwares. To run the application, whatever the softwares are required, those softwares we need to install in all the environments first, guys. Okay, right, guys. Earlier, guys, how people will work. Now we have Docker. With the Docker, we can able to do, guys. Earlier, how people will work. See, guys. Earlier, people work with virtualization. You guys have idea about virtualization, guys? Virtualization. virtualization, guys. Go to images. Right. Earlier people used to work with this virtualization concept, guys. Let me take some virtualization architecture. Virtualization. Where we don't have proper diagrams here. Fine, guys. See, guys, observe this diagram, guys. Observe this diagram. Right, see, guys, here, right, we have one computer. Inside that computer, first we should have, see, guys, first we should have the operating system. So this operating system, we will call it as host operating system. Observe carefully, guys. This is very, very important. Right, before understanding what is a Docker container, you should understand this one. Then only you guys will get the clear clarity. Observe carefully, guys. See, guys. Right, guys. So this is our computer, guys, hardware computer. On top of this, what we have, guys, operating system is available. This operating system, we will call it as host operating system. Right, in our system, what operating system is available? Windows operating system is available. That Windows operating system, we will call it as host operating system. In our system, whatever the operating system is available, that operating system, we will call it as host operating system. Right, on top of that host operating system, we need to install one software which is called as hypervisor. Hypervisor is a software, guys. What is the purpose of this hypervisor? Right, it will help us to install multiple operating systems on top of the host operating system, guys. Right, so we have the host operating system. On top of that host operating system, I want to install multiple other operating systems. If you want to install multiple other operating systems, we should have one software that is called as hypervisor. Hypervisor is a software, guys. Right, you should install this hypervisor on your Windows machine. Then only it will provide the support to install other operating systems. Observe carefully, guys. Right, this is our computer hardware devices. First, we are installing Windows operating system in our computer. That main operating system is called as host operating system. Right, on top of that Windows operating system, we need to install one software which is called as hypervisor. Right, if you install that hypervisor, right, it will give the environment, it will support to install multiple other softwares. See, guys, now I want to install 3 applications, guys. I want to run 3 applications in my system. Right, one application is running with Linux operating system. Another application is running with Ubuntu Linux. One is Amazon Linux. One is Ubuntu Linux. Another third application is running with Unix operating system. Unix operating system, right, Linux operating system, some Linux operating system, like that. See, guys, all 3 applications are using 3 different operating systems. Now, if you want to run these 3 applications in your system, right, with the help of hypervisor, you need to install the Linux operating system, you need to install the Linux operating system, you need to install the Unix operating system also. Then only you can able to run these 3 applications. Guys, this diagram is clear. Right, hardware is nothing but what? Our computer. Right, so in our computer we have the main operating system. That main operating system, we will call it as what? Host operating system. Right, on top of that host operating system, we need to install hypervisor software. Right, this hypervisor software will give the support, right, provide the environment to install multiple other operating system on top of the Windows operating system. See guys, for every application, right, different operating systems are required guys. See, one operating system is Linux operating system, second one is Linux operating system, third one is Unix operating system I'm using. Guys, now the problem is, right, on top of this operating system, if you install these many number of operating systems, what it will happen guys? Automatically your system performance will become down guys, will go down. Your system performance will go down guys. Right, sometimes if you have one operating system only, right, if you have 2 GB RAM, your systems won't run properly. Right, so now you are installing 3 other operating systems. On top of Windows operating system, you are installing 3 other operating systems, means right, your system performance will reduce. Your system, right guys, we are going to install operating systems by using hypervisors guys. So these are the different VMs. So these are the different VMs guys. One VM have Linux operating system, one VM have Linux operating system, one VM have, right, that Unix operating system. We can call these are the 3 VMs guys. All these 3 VMs having 3 different operating systems. All those things we need to install on top of Windows operating system. Because of this, what it will happen? Your system performance will go down. Right, so on top of Windows operating system, you are installing 3 other operating systems, means your system performance will go down guys. That's why people are not going to use this process. People are not so going to use this one guys. This is called virtualization. This is called as virtualization guys. Installing multiple, see guys, our main operating system, we will call it as host operating system. Whatever the other 3 operating systems you installing, those other operation systems, we will call it as guest operating systems. Host operating systems and guest operating system. Installing multiple guest operating systems in one host operating system is called as virtualization. In interview, they will ask, what is virtualization? What answer you guys will give? Installing multiple guest operating systems in one host operating system is called as virtualization. Right, here hypervisor software will be used to achieve this. How you will achieve virtualization guys? By using hypervisor software, we can achieve this virtualization. Right, we need to install all the required softwares in host operating system to run our applications. Right, it is old technique guys. It is outdated. Nowadays people are not following this virtualization process. Nowadays people are not following this virtualization. Why people are not using this virtualization? Your system performance will become slow in this process. If you go with virtualization, your system performance will go slow guys. Your system performance will become slow in this process. To overcome these problems, problems of this virtualization, we are going for containerization concept. What is containerization guys? Docker, right? We are going to use Docker guys. Understood guys? With this virtualization, whatever the problems we have, to overcome all those problems, we are going to with containerization. Is this clear guys? Why we are going for containerization? Clear? Whatever the problems we are going to face with this virtualization, right, by using containerization, we can overcome. See guys, let me add these points here. Let me add a few points. What is virtualization? What is virtualization? What is virtualization? Right, see here, installing the process of installing multiple guest operating systems on top of host operating system is called as virtualization. Is called as virtualization. Right. Here, to achieve virtualization, we need to install hypervisor. We need to install hypervisor in host operating system. Guys. Right? To achieve virtualization, we need to install hypervisor software. Hypervisor is what, guys? It is a software. We need to install hypervisor software in host operating system. Right? So we need to install all the required softwares to run the application in host operating system. We need to install all the required softwares. To run our application in host operating system. Right? If you go with this virtualization concept, if you go with virtualization process, and what it will happen, that system performance will become slow. System performance will become slow. If you go with the virtualization process, our system performance will become slow. Right? So to overcome all the problems, and whatever we have to overcome all the problems of virtualization, right, we are going with containerization concept. Right? We are going with containerization concept, guys. Understood, guys? Please go through these virtualization statements. Whatever I have given, please go through these statements, guys. What is virtualization? Please have a look into this virtualization. Right, guys? Fine, guys. So what is containerization, guys? What is containerization? What is containerization? Containerization. What is this containerization, guys? Right, guys? Containerization means what it will do, guys? It will package all the softwares and our application code. Whatever the code developers are uploaded into this GitHub repository. Whatever the code developers are uploaded into this GitHub repository, that code and whatever the softwares you want to install in all these environment, that softwares, guys. Right here, it will package all the softwares and application code in one container for the execution. Right? We are going to package everything in one container. Now, inside the container, we have the application code and all the required softwares. Now, I will run this container in all the environments. I will run the container in all the environments. Whenever you run this container in all the environments, inside the container, whatever the softwares are available and whatever the code is available, everything you will get in all the environments also. Understood, guys? Here, what I am doing with containerization, I am going to package alright our application code and the required softwares in a container, and I will run this container in all the environments. Now inside the container, whatever you have, everything you will get in all these containers also. Understood, guys? Now observe carefully. Let me draw one diagram further. Let me take virtualization versus containerization. Virtualization versus containerization. Go to images. Very good. See, guys. See? Open this diagram. See, guys. See here. Infrastructure, our computer, right, and operating system. This is virtualization, guys. Right, we are going to install, right. Let me take one beautiful diagram. Going to copy this image. I hope this diagram is clear. See, guys. In this containerization, what we are doing, guys? Right, see here, operating system is available. This operating system is host operating system. Right, on top of that, we are going to install. See, guys, this is what virtualization, guys. Right, see here, hypervisor software we are taking it here. On top of that, multiple virtual machines are there. See, virtual operating system. Right, required libraries and everything we need to install, and applications, required libraries and everything. This is called virtualization, guys. Coming to containerization, what we are doing, guys. Right here, container engine, Docker engine we are taking, guys. Right here, we are not going to install, other operating system at here. Right, container, entire container we are going to run at here. Complete container we are going to run. Right, inside the container only all the required operating systems, softwares, application code, everything is available in these containers only. Right, we are not going to install any guest operating systems in containerization. Right, or only one operating system is enough, guys. Our host operating system is enough. Right, directly we are going to run the containers at here. We are not going to install guest operating systems on top of the host operating system in containerization. See, we need to create these containers by using Docker images. Whatever the containers you have created, those containers we need to run on these environments, run on this mission, guys. That's it, guys. Right, so inside the Docker image, right, so with all our application code and with all our softwares, we are creating one image. If you have that Docker image, with that image you can able to create any number of containers, and you can run those containers in any environment. See, guys, here this hypervisor is there, and these extra operating systems we are installing. Right, here we are not going to use hypervisor, guys. Container engine is available. To run these containers, we need container engine, Docker runtime. Right, here we are going to use a Docker engine, guys. Right, with that Docker engine, we are going to run these containers. To install the operating systems, how we are using hypervisor software, same way to run these containers, we need one containerization engine, Docker engine we are going to use here to run these containers. Understood guys? Difference is clear? Difference is clear guys? With the hypervisor, sorry, this virtualization and containerization clear? Here we are using hypervisor as the extra software. Instead of hypervisor, here we are using containerization. And here you are installing the softwares on top of the host operating system, and on top of the host operating system you are installing guest operating systems. But here we are not going to install any other softwares. By using this Docker engine, directly we are going to run our Docker containers. Understood? So let me add those points here. What is containerization? What is containerization guys? Right, installing, right, it is containerization. We will use containerization, containerization. We will use containerization to package all the required softwares, and application code in one container. In one container guys, we will use this containerization. We will use containerization to package all the required softwares and our application code in one container for execution. For execution guys, we will run that container directly, right? Container will take off everything which is required to run our application guys. And here we are not taking care of that guys. We are not taking care of that. Right? If you go with virtualization, there we need to install. See guys, here I have written, right, here we need to install, right, see where I have written, see guys, all the required, right, we need to install all the required softwares to run our application guys. But here whatever the softwares are required, so all those who will take care of that installation part guys? We no need to take care. My container will take care of that installation part and everything, right? Here just we need to run the container guys, right? That container will take care of everything which is required to run our application. Complete environment will be taken care by the container only. Understood guys? Here to run our application, whatever we required, everything will be taken care by container only. Run our application, whatever we required, everything will be taken care by container only. We no need to install anything at here, right? So here what we are going to use for containerization guys? Docker is a containerization software. Here Docker is a containerization software. Docker is a containerization software which we are going to use guys, right? Using this Docker, right, by using Docker containers, we can run our application. Guys by using Docker containers, right? So we can run our application guys. Using Docker, we will create, 1 minute guys, let me change this statement. By using Docker, we will create containers guys. By using Docker, we will create containers for our application. Whatever the containers are required, we can create those containers by using Docker guys, right? So we will create the Docker containers, right, using, right, guys, by using Docker, we will create Docker images also. We will create Docker image for our application. See guys, from this Docker image only we will create the Docker container, guys. Right, first we will create the Docker image. If you have the Docker image, you can create any number of containers at here, guys. Right? Docker images we can share easily to multiple machines, guys. Right? If you have the Docker images, we can share to multiple machines easily. Right? Using this Docker image, we can create the Docker containers. Right, using Docker images, we can create the Docker containers, guys. If you have the Docker image, by using the Docker image, we can create the Docker container and we can execute that container, guys. And we can run that container. 1 minute. So using Docker image, we can create the Docker container and we can run that container, guys. We can run that container. Please go through these statements, guys. What is containerization? See, guys, observe carefully. Here, what we are going to take, observe carefully, guys. Here I have the application with Docker. Here I have the application with Docker, guys. Application with Docker we have. Application with Docker we have, guys. Here we have the application with Docker. Application with Docker we have. Right, from this, what we are going to do, guys? From this, we need to create one Docker image, guys. From this, we need to create one Docker image. Docker image we need to create here. Docker image we need to create here. Right. So if you have the Docker image, right, you can share this Docker image with multiple machines. Right, here I have mission 1. Right, here I have mission 2. And I have mission 3. Like this, multiple missions are available. Right, in all these missions, you can able to share this Docker image, guys. Here, Docker container will run, guys. Docker container. Here also, we have this Docker container. Here also, a Docker container will execute in all the missions, guys. Right, this is mission 1, mission 2, mission 3, guys. Like this, guys. This is mission 1. VM1. VM2, VM3. Like this, we have multiple missions. In all the missions, we can run this container, guys. Fine, guys. Now observe carefully, guys. Docker, guys. Right, Docker container. If you observe this Docker container, how it look like the image, guys. See, Docker container image.
Excuse me, sir. Like the same thing can be done for the virtualization also. Now we can create an image with all the dependencies, and we can create the environments with the virtualization.
In virtual machine, you need to install virtualization. You need to install multiple operating systems, right?
Multiple operating system we need to install, but in containers we cannot have like Linux containers on Windows machine.
It will come. Whatever the see here, whatever the softwares are required, whatever the applications are required, operating system also will come in that.
In the sense, in containers we don't have operating system, correct?
Containers?
We don't have operating system.
No. Here what we need to do, if you go with virtualization, explicitly you need to install the operating systems on top of that our host operating system.
Yes.
Right, but coming to containerization, we no need to install the operating systems. Inside the container only you will get the required softwares, operating systems and application code, everything. Just we need to run that container, that's it. We no need to install all those things again.
In the sense, like for example, if it is the server is a Windows server, and we cannot run Linux containers, no, on that.
No. In Windows also you can run, but in Windows, suppose if you want to practice Linux, right, in Windows, right, so what you need to do, you need to install the Linux operating system, right? How you will install the Linux operating system in Windows? Either by using hypervisor or by using VirtualBox also we can use. Right here, Linux operating system and Windows operating system both have in same mission. At that time, performance will slow down, your system speed will reduce. Only because of that performance issue only we are going with this containerization.
Yeah, like if it is the same operating system, it works in the containers. But if it is
in real time, we won't use Windows operating system, right?
Okay.
In companies, if you go to any project, we won't use Windows operating system. Windows operating systems we will use just for developing the code, just for creating the code. Coming to deployment, we want Windows operating system in any project.
Okay. Because even the images can be created for the virtual machines. So that's what I was thinking.
We will discuss all those things.
Okay, thank you.
See guys, so this is the container image, guys. See, so these are the containers, how it is showing. Inside the containers, why it is showing the containers, guys? Inside the containers, we are going to package all the required softwares to run our application and application code, everything we are going to package inside a container. And why they have given this ship logo, guys? Ship, this is the ship logo. So these containers we can able to move, right? Easily we can transfer the containers from one location to another location. Shippable. All the containers easily we can able to, right, transfer from one location to another location. That's why they have given this ship logo, guys. Right, these containers are shippable, guys. Right, any mission, right, in which mission you want to run that container, you can ship those containers to those missions, guys. Right, in which mission, in dev environment you want, a sit environment you want, a UAT environment you want, in which mission you want, easily you can transfer, you can send these containers to those missions. So that's why they have given, right, the ship image and this containers image, guys. Okay. Fine, guys. So this is the course content which we are going to discuss in the next 25 to 30 days. After that, see here, just we had, right, just I have given basic introduction. Basic introduction I have given about what is virtualization, what is containerization, right? So what components are available in application development, right? Front-end component, back-end component, database component, right? What softwares are required to implement all these components, right? So how many environments we have in the companies, right? How we are going to deploy our application in all those environments, right? We discussed, guys. Just demo kind of thing we discussed. From tomorrow onwards, we will start our actual content, guys. Okay. So any doubt course content wise, any questions, guys? You guys have any questions course content wise? Fine, guys. Right, tomorrow we will have the session at 7:30 same time. Right, guys. We will discuss in tomorrow session. Someone is asking something.
Is there any batch starting in the morning?
For what, man? Only for Docker and Kubernetes?
Yes.
No batch. Morning time it will take some time. Now only AWS is running for morning batch. Right, I need to start the DevOps for morning batch from coming Monday. I'm going to start the DevOps for morning batch. Right, it will take some time. It will take some time for morning batch. It will take at least 1.5 months. It will take.
Okay. For DevOps,
From Monday onwards, I'm going to start DevOps for morning batch.
Sir, in DevOps, this Kubernetes and Dockers will
Yeah. In the DevOps, you will get Kubernetes and Docker also.
Okay.
Morning at 7:45, we have the batch. 7:45 to up to 9:15, I will take the session. Right. So there, I'm going to start the DevOps from Monday onwards. Right. There, this Kubernetes and Docker also will come.
Okay. Thank you.
Okay, guys. Right. We will discuss remaining things in tomorrow's session, guys. Thank you, guys. Thanks for joining. Tomorrow we will continue. Thank you, guys. Good night.